In this video, we're going to multiply radicals. And rather than multiplying single radicals, we're going to multiply a sum or difference of radicals. And so I've got a problem that's up here. Now the secret to this is to distribute properly. And then we're going to take it one small step at a time and just walk through it slowly. All right, let's go ahead and get started. I want to distribute these two binomials in order to multiply them. If you want to use the dirty four-letter F word, you can. That's okay. I'm just against it because then most students don't realize you're actually using the distributive property, and that's a very important property. So we distribute this 2 roots of 3x over to the 5 roots of 3x cubed, and also to the negative 6 roots of y. I'm just going to simply write that out. 2 square roots of 3x times 5 square roots of 3x cubed minus, that's this minus here, 2 roots of 3x times 6 roots of y. All I did is distribute. Okay, so now in blue, I'm going to take the second term of the first factor along with its sign, and I'm going to distribute that to the terms of the second factor. And so I have a positive root of y cubed times 5 roots of 3x cubed gives me a positive root y cubed times 5 roots of 3x cubed. And then I have a positive roots of y cubed, or root of y cubed minus 6. So when I'm multiplying those two things, I'm really saying positive times a negative is a negative root y cubed times 6 roots of y. Okay, so now this makes sense. If we take two binomials and we distribute them under multiplication, we should end up with 4 terms. And we have 4 terms. 1, 2, 3, and 4. Now, some of these terms may be able to be combined. However, we have to look at the rules of adding and subtracting radicals. And if you don't recall those, you have 2 conditions you have to satisfy. 1, they have to have the same index, same indices. 2, they have to have the same radicands, the things underneath. Radicands. Okay, that's to add or subtract. But we're going to want to keep that in mind when we get to this after this next step. For the next step, what we're going to do is we are going to go ahead and perform the individual multiplication in the individual terms. And so recall that when you multiply, as long as you have the same radicals, or same the same indices, like you have a square and a square root here, then you multiply the things inside. And so I'm just going to simply do that. 2 times 5 is 10. Now I have the same index for both radicals, and so I'm going to multiply the things inside underneath the radical. That gives us 9x to the 4th. I have 1x here, 3x is here, gives me 4x's multiplying total. On the next term, 2 times 6 is 12. Now, since they are the same radical, or the same index, I can go ahead and multiply what's inside. I just can't do much more than that. Where I could combine the x and the x cubed here for x to the 4th, x and y don't combine like that. Plus, now switch to blue so that you know which side I'm on. Root of y cubed, so I have an imaginary 1 out here. 1 times 5 is 5. I have the same index, so I can combine what's underneath. That gives me 3x cubed y cubed. And then finally minus, and I have 1, an imaginary 1 out front, times 6 is 6. Under the radical, I have y cubed and y for a total of y to the 4th. Okay, at this point, we are simplifying. I would simplify first before I try to add or subtract. And so I ask, this is 10 times. Okay, is 9 a perfect square? Because I'm taking the square root of 9. And it is. And so the square root of 9 is 3, and I'm multiplying it in. The square root of x to the fourth, well, if I look at the 2 out here, I can say I'm pulling out groups of 2 x's. How many groups of 2 are in 4? There are 2 groups of 2 in 4. There's no leftovers, so there's nothing to put back in under the root. Minus 12. Now 3 is not a perfect square. There's no square or higher on x or y, and so that just stays. There's nothing to bring out there. Plus. And now on this one, we do have something to bring out. 3 is not a perfect square, nor does it have a perfect square factor, and so we look at bringing out groups of 2 from x and y. And we notice that we can bring out one group of 2 on the x's, but that's going to leave us with 1 x left over. 3 divided by 2 is 1 with a remainder of 1. The remainder goes back inside. Same thing with the y. 2 divided into 3 gives us 1 with a remainder of 1. And so I can bring out an x and a y, but I still have an x and a y underneath. And then I subtract 6, and the square root 6 times the square root of y to the fourth is the same as x to the fourth here. We just have y squared. At this point, I'm going to clean it up a little bit so that I have 10 times 3 is 30x squared minus 12 roots of 3xy plus 5xy roots of 3xy minus 6y squared. Okay, so now that it's cleaned up, I can take a look and see, can I combine any radicals? And remember, we have two conditions. The indices must be the same, and the radicands must be the same. Well, 3xy and 3xy, the radicands are the same. This is an understood 2, and this is an understood 2. And so those are the same. So to do this, what I do then is I combine, since I have x's and y's in the coefficients, I can't really subtract them or add them together. However, I can factor out that radical. Okay, and so that's going to factor out this piece here. If I factor out that radical, it's going to give me negative 12 plus 5xy in parentheses, and then underneath the radical is 3xy. What I'm going to do in this next step is I'm going to reverse the order of the negative 12 and the 5xy. And I can do that because I'm commuting across addition. I'm also going to move my 6y squared to the front with x squared. It just tends to look nicer. That's the only reason. There's no mathematical reason to do it. And so I have 30x squared minus 6y squared plus, I want to put a plus here because I took this whole thing in green. I took that whole mess in green. And so I'm adding that chunk in. And that's going to give me 5xy minus 12 roots of 3xy. There's your answer. It's not much of an answer. I mean, still looks awful, but you have successfully multiplied it out.